Great. Thank you, Jason, and happy to be here. So this is work joined with Jens Witkowski, Lyle, Ungar, Barbara Mellers, and Phil Tetlock. This is an empirical paper. So the main point of our work was to discover who is good at forecasting with limited information, in particular information about their belief updating propensities. Just a second. So usually we think of forecasting in a one-shot situation. So we might see that the judge has made some kind of probability judgment about, let's say, the probability that a given candidate will win the election, and then we might consider what kind of signals that this judge is seeing or this forecaster is seeing, and try to judge their accuracy or the validity of their forecast by that. But in many real world cases, forecasters have the ability to update their forecast over time. So in this case, as the forecaster learns more information, they can change their forecast. In this case, it's from the 20s to the 40s, down to about 10%. And those choices that the forecasters make to update their beliefs at T1, 2, etc., could tell us something about how this forecaster is approaching the task, and maybe something about the accuracy of this forecaster on this question, but also on other questions. So we used data from the Good Judgment Project. Jens Witkowski and I were postdocs at this project, and during this work, it was part of a IARPA-sponsored forecasting tournament. We collected the largest data set on human probability predictive judgments, at least outside of sports. And it focused on geopolitics, economic, public health, and related topics. And one thing that we found, a key result, was that forecasting accuracy is a matter of skill, not just luck. So that if we can figure out who the skilled forecasters are early, we can create better aggregations and more accurate crowd forecasts. Now, it is one of the most straightforward ways to capture who is skilled is just to look at their historical accuracy. However, in some cases, we have limited data on historical accuracy. If you're, for example, considering forecast on existential risk, or general AI posing existential risk, so many of the questions will take so much time to resolve, and if there's an existential catastrophe, we won't even be able to score the question. So in some cases, you can't really establish a accuracy track record. Other cases are, for example, global warming, where by the time you've resolved a bunch of questions, it may be too late. So you want an early marker of accuracy. And sometimes even elections, like in the US, where all of the outcomes from an election come at the same time. So you don't have time to accumulate, at least within an election cycle, to accumulate accuracy track record. And there are a variety of tools for examining accuracy. One is proxy scores, but the one that we stopped on was belief updating. So the question we're focusing on are, what are the marks of accurate forecasters especially in terms of belief updating, and that is informed by understanding if forecasters on average underreact or overreact to new information. So if the average forecaster underreacts to new information, then someone who underreacts less may attain an advantage over time as they update their beliefs more and more. And similarly, if it's the case that the average forecasters overreacts, then those who overreact less could yield an advantage over time. There are two opposing biases in updating. Underreaction has been well studied in the psychology literature. It is related to what Ward Edwards called cognitive conservatism or Bayesian conservatism, the idea that when judges or forecasters view signals, they update in the direction of the signals, but not enough. This is also related to the anchoring and under adjustment heuristic and confirmation bias as well, that forecasters are looking for information that is consistent with their pre-existing beliefs. On the other hand, there are behavioral reason to expect that forecaster may be overreacting to new information. And that are the cases when they find new examples or new pieces of evidence that are representative of the case at hand, or due to the availability heuristic, when they find a single piece of evidence that seems that seems to outstrip all other pieces of evidence and importance. And forecasters also attend to extreme observations. So if something is extreme or extremely unlikely, they're likely to pay too much attention to it. And so we wanted to understand if there's under or overreaction in the aggregate, and if that has a relation to who the most accurate forecasters are. Now, it's tempting to think about belief updating in a one dimension. So less or more, and the forecaster who update the least, we can call them belief perseverant, and those who update the most, we can call them flip-floppers. And in that model, the best you can do is be somewhere in the middle. But we found that it is very important to distinguish between different dimensions or different aspects of forecasting, and so that a one-dimensional analysis does miss a lot. And so we distinguish between frequency, magnitude, and confirmation propensity. How does this work? So in this case, the forecaster makes 3 forecasts for that question. Those are signified by the 3 red dots. So the frequency of their updating is 3 per question for this one. Notice the black dot in the middle. This is a case where the forecaster just logs in and places a forecast to this question that's identical to the one that they previously had reported. This is what we call confirmation. And in this case, confirmations are one quarter of all the forecast play. So that's the confirmation propensity is rated as 25%. And the magnitude is simply the average absolute size of the updates. So in this case, it would be about 27%. This is the average length of the vertical lines. And we examined also squared distance, but the results are pretty much identical, whether we do absolute or squared distance. And we measured accuracy of the forecasters using the BRIER score, a proper quadratic scoring rule. In this case, it is useful to know that we're looking at accuracy during the forecaster's first judgment, first forecast, their last judgment, and overall, which is basically the scores of the forecasts that they placed throughout the time the question was open. So for every day, the forecaster gets scored, and we average over days or times. And this was known to all forecasters at the start of the tournament. For this study, we looked at forecasts from just over 500 forecasters who made just over 80,000 probability judgments on just under 500 questions. And the average forecaster made at least one update on 43 questions. So we had a dense data set of user behavior. And the average forecaster made 2 forecasts per question, so 1 new forecast and 1 update. When they updated, the average update size was 0.2, so like that would be for example, from 30 to 50% on the probability scale. And 19% of the forecasts were confirmations. So 19% of the time when somebody came to place a forecast, that was identical to what they had previously registered. And since we had just over 40 questions on average per user, what we did was we validated across samples of questions. So we might measure the belief updating across one set of questions. So in this case, that was oil price and Merkel re-election, and then we can see how the forecaster does in terms of Greece leaving the Eurozone and the Syrian conflict. And we had multiple cross-validation iterations where we picked different samples of questions for training versus validation and vice versa. And we examined if belief updating in one set of questions predicts accuracy in another set of questions. So first of all, we wanted to establish reliability. So how reliable is each measure across each set of, the two sets of questions? On average, frequency was very highly correlated between sets of questions. So if I know that the forecaster updates frequently, that's a very reliable measure that they'll update frequently in a held out set. Magnitude, the absolute size of updates was also quite, it was less reliable, as was confirmation propensity, and standardized BRIER score or accuracy had the lowest test-retest correlation. And so that tells us that when we have small sizes, small sets of forecasts, sometimes we may be better off looking at the most reliable measures, the ones that are more likely to be sustained. And here we're looking at standardized BRIER scores, so 0 is average performance and higher scores are worse. Just for the purposes of illustrating the findings, we separated forecasters using a median split into large versus small updaters. So larger ones had a update size on average above 20.2, and infrequent versus frequent updaters. The core analysis is continuous, but just for the purposes of illustrating, we wanted to show it in terms of this median split. And so what we see is that the worst forecasters are the large and frequent updaters, and the best forecasters are the small and frequent ones. So the ones who make many updates on their forecast, but those updates are on average small. We are also interested how this accuracy changes over time. The idea was that maybe it's not the updating per se that makes small updaters better, but it may be that they had the correct forecast at the start, and so then they correctly foresaw that they don't need to make large adjustments. And indeed, that was the case. So if we look at the 3 periods within a question, the start, middle, and end. So if a question is last 30 days, the first 10 days, the second 10 days, and the third period of 10 days, we would see that the small updaters do best at the start of questions. Their initial judgments are unusually accurate. But the small updaters, in fact, do not do very well over time. And the high frequency updaters do the best over time. So their scores in aggregate decrease over time. And so initially, the best forecasters are those who tend to make small adjustments, but at the end, the best forecasters are ones who tend to make more frequent adjustments, and the size matters less. Now, we also wanted to see if forecasters are underreacting or overreacting, and to do that, we just simulated their updating size. So the black line is the actual updating pattern of a forecaster, and then we could simulate by saying, what if we made the updates larger or smaller than they actually were? So there was no stochastic component. We just increased or decreased the size of the updates, and we then measured the accuracy of that last forecast. If forecasters were underreacting to information, then increasing the size of their updates would have helped would have improved their accuracy. But what we found was that on average, so here on the x-axis, we're seeing the belief updating magnitude. 100% means it's the observed one. So we can make the updated magnitude smaller, and that would make the forecast worse. So the BRIER scores index to actual just means that if the forecasters made 70%, if the update sizes were reduced by 30%, they would have had 4% worse or higher BRIER scores. So we could make us worse by making the update smaller, but we couldn't really improve the accuracy by making forecasts larger. So the maximum improvement in accuracy we could get was 0.3 percentage points. And that was, just to give you a sense of the magnitude, if we had just picked the small frequent updaters, those would have been better by 30% than the infrequent large updaters. So it matters a lot which forecasters you pick in your average, but improving their updates by making them larger makes much smaller, 100 times a smaller difference. So on average, forecasters were well calibrated in terms of the size of their updates. You did not pose a significant bias in either direction. We also looked at training. So we randomly assigned some forecasters to be trained, and we looked at how the effect of training is being mediated by frequency. So are trained forecasters better because they update more frequently? And that, to some extent, that was the case. Frequency mediated 17% of the effect of training. The mediating effect of magnitude was larger. It accounted for 30% of the effect of training. So basically, when we train forecasters, they made smaller updates, and that in turn improved their accuracy, even though we did not specifically tell forecasters to make smaller updates. We also looked at how forecasters were working. So we measured their political knowledge as well as open-mindedness and their engagement. So how often they log in, how often they click on links. And the frequent updaters were very high in those traits. And we'd like to say that in terms of information processing, they were going for quantity. They had processed more information, had more knowledge from the start, and then continued to seek more information. And frequency was related to that. Magnitude, on the other hand, was unrelated to any kind of effort or engagement metrics that we collected. And it was magnitude was connected to training. So trained forecasters made smaller updates, and also forecasters higher in fluid intelligence or IQ also tended to make smaller updates. And so we'd like to think of the latent feature of quality of information processing. So it seemed that the small updaters, the small increment updaters, tended to process information better without seeming to spend any more effort or to be more highly engaged with the task. So in conclusion, a pattern of small frequent updates and rare confirmations, so those who rarely confirm their forecast, those three patterns robustly identified skilled forecasters, those who are likely to be accurate in a held out set of questions. Incremental updaters perform best at the start of questions with their initial judgments, while frequent updaters tended to increase their advantage over time and were best at the end of questions. And forecasters did not exhibit a consistent bias towards either overreaction or underreaction to new information. Rather, the identification came from, at least in terms of magnitude, came from the idea that the small updaters correctly perceived that their initial forecasts were relatively accurate, and they didn't need to make large adjustment after their initial estimate. And so I have. Thank you.